Hello student, we start exercise 6.5, sum number 3 and sub question is 4. Okay, here we want to find the local maximum and local minimum value of the given function. So here first we derive it with respect to x. It is cos x plus sin x and double dash x is minus sin x plus cos x. Right? This is our result 1 and this is our result 2. Now we put f dash x equal to 0. Now f dash x equal to 0, it means tan x equal to minus 1. From here, tan x equal to minus 1. Now from the unit circle, we know that at second quadrant and fourth quadrant, tan become negative. So here 3 pi by 4 is answer and here 2 pi minus pi by 4 is 7 pi by 4 is answer, right? So therefore x equal to either 3 pi by 4 or 7 pi by 4. Now just we check it. For x equal to 3 pi by 4, put in 2. F double dash 3 pi by 4. Here one thing you remember that here minus sin 3 pi by 4 plus cos 3 pi by 4. Here sin is positive in second quadrant and cos is negative. So ultimate minus 1 upon root 2 minus 1 upon root 2. It is minus root 2, it is less than 0. So therefore at x equal to 3 pi by 4, fx get local maxima. And the value is f3 pi by 4. Here just we put this value here. So it is sin 3 pi by 4 minus cos 3 pi by 4. It is root 1 upon root 2 plus 1 upon root 2. It is root 2. Right? So this is our first value. Now we go for the second one. For x equal to 7 pi by 4. So we have f double dash 7 pi by 4. It is minus sin 7 pi by 4 plus cos 7 pi by 4, right? So it is minus 1 upon, plus 1 upon root 2 plus 1 upon root 2, it is root 2 greater than 0. Therefore at x equal to 7 pi by 4, fx get local minima, right? Now local minima, so what is the value? f 7 pi by 4. So it is sin 7 pi by 4 minus cos 7 pi by 4. So sin 7 pi by 4 minus cos 7 pi by 4. Minus 1 upon root 2 minus 1 upon root 2, it is minus root 2. So this is local minima and this is local maxima, right? So this way we can find local minima and local maxima of the given function, right? Now we go for the next one. Okay, next 5. fx equal to x cube minus 6x square plus 9x plus 15. So here first we find f dash x, which is 3x square minus 12x plus 9 and then f double dash x. So it is 6x minus 12. Now this is, here we just simplify it, then x square minus 4x plus 3. It is 3 bracket x minus 3 and x minus 1. So there are two critical value, 3 and 1. Okay. So remember this thing very carefully, that this is our first answer and this is second answer. Now we put f dash x equal to 0. It means x equal to 3 or x equal to 1. Okay. Now for x equal to 1, f double dash 1 is equal to 6 into 1 minus 12, it is minus 6, it is less than 0. Therefore at x equal to 1, fx gets local maxima and the value is f1. It is 1 minus 6 plus 9 plus 15, it is 19. It is 19. The so first value is 19 and the second value is defined. This is 19, right? So this is local maxima. Now for x equal to 3, f double dash 3, it is 18 minus 12, it is 6 is greater than 0. Therefore at x equal to 3, fx get local minima, right? Therefore, and the value is f3, it is 27 minus 54 plus 27 plus 15. So answer is 15 because this 27 and 54 are cancelled. Therefore, local minima is 15 and local maxima is 19. So this way we can find the local minima and local maxima of the given function, right? Okay, then we go for the next one. Okay, then next sum is gx equal to x by 2 plus 2x, x is greater than 0, right? So in this sum, first we find g dash x, it is 1 by 2 minus 2 upon x square. Then g double dash x, it is 2 into minus 2 raised to x raised to minus 3, and this is minus. Okay, so here 4 upon x cube, right? So first answer is this and second answer is this. Now we put g dash x is equal to 0. It means 2 by x square is 1 by 2, or x square is 4, therefore x is plus or minus 2. But x is greater than 0, therefore we can take only x equal to 2. Now put x equal to 2 in 2. We get f2 is equal to 4 by 8. It is 1 by 2. It is greater than 0. Therefore at x equal to 2, gx gets local minima. And this is g. So g double dash 2. Okay. So g2 is equal to 2 by 2 plus 2 by 2 is 2. Therefore, local minima is 2 by 2, local maxima is not obtained at all, right? Local maxima is not obtained. Okay, then we go for the next one. Okay, next seventh one, gx is equal to 1 upon x square plus 2. So here g dash x is equal to minus 2x upon x square plus 2 whole square, right? Now we find g double dash x. It is quite difficult, but minus 2 we take outside. G double dash x. Now denominator as it is, derivative of numerator minus numerator is 1 minus numerator as it is, derivative of denominator is 2x square plus 2 into 2x upon denominator square, x square plus 2 raised to 4, right? And now we just simplify it. So we have minus 2 bracket x square plus 2 is common, and we have left is x4 x square plus 2 4x square. Okay, so here g double dash x is minus 2 x square plus 2 bracket minus 2 x square plus 2 upon x square plus 2 raised to 4. Now we just take g dash x equal to 0. It means x equal to 0, right? So directly put in 1, we get g double dash 0 is equal to minus 2, here 2 into 2 upon 16. So it is minus 8 by 16 or 1 by 2, which is less than 0. Therefore at x equal to 0, gx gets local maximum, and the maximum value is gx or g0 is equal to 1 by 2. Okay, so this way, and local minima is not obtained. Local minima not obtained. So this way we can find our answer. Now we go for the next one. Okay, next 8. Fx equal to x root 1 minus x, where x is greater than 0. So here f dash x is equal to minus 1 upon 2 root 1 minus x plus root 1 minus x. It is minus x plus 2 1 minus x upon root 2 root 1 minus x. It is minus 3x plus 2 upon 2 root 1 minus x. This is our first result. Now we find the second order derivative, f double dash x. It is quite different, but 1 by 2 we put as it is, denominator as it is, minus 3 minus 2 minus 3x as it is, minus 1 upon 2 root 1 minus x upon denominator square, means 1 minus x. Okay, now when we simplify it, we get, we get this answer, 1 by 2 3x minus 4 2 upon 2 root 1 minus x raised to 3 by 2. Now put f dash x equal to 0. It means x equal to 2 by 3. Put in 2. We get f double dash 2 by 3. It is 1 by 2 into 2 minus 4 upon 1 minus 1 by 3 raised to 2 by 3, 3 by 2. This is negative. Okay, ultimate answer is negative. So therefore ultimate answer is negative. Therefore we can say that at x equal to 2 by 3, fx get local maxima, and the value is f 2 by 3. It is 2 by 3 root 1 minus 2 by 3. It is 2 by 3 into 1 upon root means 1 by 3, 1 upon root 3. It's 2 upon 3 root 3. Right? So this is our 3 root 3. This is our local maximum value. Local minimum not obtained. Not obtained. Right? Okay. Then we go for the next one. Now this third sum is completed. Now we go for the fourth one. Okay, in fourth sum we want to prove that this function has neither local maxima, neither maxima or minima. So first of all, f dash x is equal to e raised to x, which is always greater than 0 or which is always positive for every x belongs to R. Therefore, f dash x neither f dash x is 0 is not possible. If this is not possible, then we can say that therefore no critical value of fx is f dash x is obtained. Therefore our test is failed, and therefore no local minima or maxima is obtained. Right? So this way this function has neither local minima nor local maxima is obtained. Now the same way here the next function is fx equal to log x. Here the log x is also same kind of function, f dash x equal to 1 upon x, and it is always greater than 0, or it is belongs to R but never becomes 0. Okay, so this is never becomes 0, therefore we can say that f dash x not equal to 0, therefore no local maxima or minima are obtained. Right? So this way in this function also we get the same answer, that this function has neither local minima nor local maxima. Okay, then we go for the next one, which is the third one. Third sum is hx equal to x cube plus x square plus x plus 1. So h dash x is equal to 3x square plus 2x plus 1. Now here the factorization of this term is not possible, and it is always greater than 0. Therefore h dash x never becomes 0, and therefore no critical value is obtained, and hx has neither local maxima nor minima. Right? So this way this sum is also completed. Now we go for the fifth one. In this fifth one we want to find the absolute value of the given function. Okay, in this fifth one we want to find the absolute maximum value and absolute minimum value of the following function in the given interval. So here what we do, we want to find absolute means global maximum or global minimum. So first of all we find f dash x, which is 3x square, and put it is 0. Therefore x equal to 0. Now we have three values. First is f0, which is 0. Second is f minus 2. Right here this is minus 8, and f2 is equal to 8. So for global or absolute maximum value of fx is equal to maximum value of f0, f minus 2 and f2. We want to take all these values which are in critical point as well as in our interval. Okay, so here the maximum value of 0, minus 8 and 8, it is 8. Therefore absolute value and maximum value is 8. Now for absolute minimum value of fx, we can take minimum value of f0, f minus 2 and f2, right? It is minimum value of 0, minus 8 and 8, it is minus 8. Therefore absolute minimum value is minus 8. Okay, this is very easy, so you can do it is or you can understand it is very easily, right? So remember this thing very carefully, that for finding absolute value we just find the first derivative and then critical point. First derivative is 0, critical point is obtained, we find the value of function at critical point, as well as in given intervals absolute value, means -2 and 2 at the end of the interval. Okay, so there are three values can be obtained: f0, f-2, f2, which are respectively 0, -8 and 8. When we want to find absolute maximum value, it is 8, and absolute minimum value, it is -8. Okay, then we go for the next one. Okay, for the second one, this is the trigonometrical function, so be careful. F dash x is equal to cos x minus sin x, cos x minus sin x, and we put f dash x equal to 0, tan x equal to 1. Tan x equal to 1, which is possible in only one quadrant, which is the first one, implies it is possible for tan pi by 4, because here the interval is given 0 to pi. So only first and second quadrant are obtained. In first quadrant tan is positive, therefore x is pi by 4. Right? So we just find f pi by 4. It is sin pi by 4 plus cos pi by 4. It is 1 upon root 2 plus 1 upon root 2. It is root 2. This is our first value. Then the second value is the critical value, 0. It is sin 0 plus cos 0. It is 1. F pi, it is sin pi plus cos pi. It is -1. Therefore, absolute maximum value of fx is the maximum value of f pi by 4, f0 and f pi. Now here maximum value of f pi by 4 is root 2, then 0 is 1 and -1. Here root 2 is the maximum value, right? So therefore absolute maximum value is root 2. Now for minimum value it is -1, but absolute minimum value of fx is minimum value of f pi by 4, f0 and f pi. It is minimum value of root 2, 1 and -1. It is -1. Therefore absolute minimum value is -1. So this way the absolute maximum value of fx is root 2 and absolute minimum value is -1. Okay, so this way we can find our answer. So this is also a good sum, because here we want to find absolute maximum and minimum. So there are difference between absolute and local maximum minimum value. In local, we want to find first derivative, second derivative, first derivative equal to 0, and then the critical point is obtained, and we put in the second derivative, and plus or minus, according to plus or minus, local minimum or maximum value is obtained. But in this absolute value, global value, we can directly put f dash x equal to 0, then we find one critical point, then directly you find the critical value of the given function, and the end point of the interval is also given. So end point of the interval means two extremities of the interval are also necessarily needed here. So we take pi by 4, 0 and pi, and for these three values we find the value of fx, and then we get the answer. First is root 2 and second is -1 in absolute maximum value and absolute minimum value. So this is very important, so be careful. Here two methods are there and two different methods, and slightly difference is there. So remember it is carefully, and we do the next sum in our next chapter, next lecture. Okay, goodbye and have a nice day. Okay, thank you.